It feels like we all just got comfortable with 5G, right? But the truth is, the next giant leap in wireless is already being built. Today, we're going to look way beyond our current networks to explore the incredible science and, yeah, the huge challenges behind 6G. And this is a technology that promises to do a whole lot more than just speed up our downloads. It's really set to reshape our world. So you might be asking, why do we even need 6G already? Well, think of our current wireless networks like a massive highway. For years, we've just been adding more and more lanes for all the data traffic. The problem is, that highway is now completely packed, bumper to bumper, and we are heading straight for a global digital gridlock. So what do you do when there's just no more room to build? Well, we're going to follow the engineers on their search for a solution. They're looking for a brand new, almost completely empty digital frontier that could solve this massive data bottleneck once and for all. All right, first things first. Let's really break down exactly why our current networks are under so much pressure. What is causing this just unbelievable demand for data? And the funny thing is, the very technologies causing this strain are the ones we're all so excited about. That crystal clear Ultra HD video you stream, those immersive AR and VR worlds that are just around the corner, and a planet with billions of smart devices all talking to each other, they all demand a colossal amount of bandwidth that's eventually going to overwhelm even our best 5G networks. So the engineers had to find completely new territory, and they found it. They found this massive, untapped part of the wireless spectrum, a totally new digital frontier for the next generation of technology. This is terahertz, or THZ, communication. And if we go back to that highway analogy, if our current networks are a congested city freeway at rush hour, the terahertz spectrum is like a brand new 16-lane superhighway stretching across an entire continent. And the best part? Right now, it's virtually empty. And the potential here it's just staggering. We are not talking about a small speed boost. We're talking about data rates measured in terabits per second. That's 1,000 times faster than 1 gigabit per second. I mean, imagine downloading hundreds of HD movies in a single second. It is a truly mind-boggling leap in what's possible. But, of course, it is not that simple. This incredible new frontier comes with a huge catch, a whole series of challenges that are rooted in the basic laws of physics, making it incredibly difficult to actually use. To really get the challenge, you just have to see how different these waves are. Your current Wi-Fi or 5G signal is kind of like a floodlight. It spreads out, covers a wide area, and passes right through most walls. But terahertz waves are like a laser pointer. They're incredibly focused and directional, but they're also fragile and have a really, really short range. And when I say fragile, I mean really fragile. The signal weakens dramatically over a pretty short distance. That's called severe path loss. But here's the really wild part. The very molecules in the air, especially water vapor, can stop it cold. A rainy or foggy day could completely absorb the signal, which is a massive, massive challenge if you want reliable communication. So how do you build a network with waves that can't go through walls and get stopped by a little bit of rain? Well, this is where the engineering becomes just incredibly clever. It's all about building a new toolkit to basically outsmart physics. Okay, the first tool is called Ultramassive MIMO. It stands for Multiple Input, Multiple Output. Just imagine a base station with not one, but thousands of tiny antennas all working together. This giant array creates and steers those laser pointer beams of data with pinpoint accuracy, focusing all of its energy directly at your device instead of wasting it by spraying it everywhere. Okay, but what happens when you walk behind a pillar or a wall? That's where Reconfigurable Intelligent Surfaces, or RIS, come into play. The easiest way to think about these is as smart mirrors for radio waves. You can coat a wall or a billboard with this material, and it will intelligently catch an incoming THZ beam and bounce it perfectly around the corner directly to you. It's kind of like playing a perfect game of pool, but with data signals. Now, trying to orchestrate all of this, thousands of beams, countless smart mirrors, and people constantly moving around, is impossibly complex for any traditional system. This is exactly why artificial intelligence is the absolute brain of the operation. The AI is constantly sensing the environment, tracking you in real time to keep that laser beam locked onto your device, and telling all those smart mirrors exactly how to angle themselves. It makes the entire network a living, intelligent system. So, we have this unbelievably fast and intelligent network. But the true revolution, the part that's really going to change everything, is a fascinating side effect of all this technology.
See, because these THZ signals are constantly bouncing off everything in the environment to find you, the network can analyze those reflections. This is called Integrated Sensing and Communication, or ISAC. It means the network isn't just communicating, it's simultaneously sensing the physical world around you, and with millimeter-level precision. It could create a real-time map of a room, track your gestures to control your smart home, or even monitor your vital signs from a distance. The network literally gains a new sense it can see.
And that right there is the core takeaway. This isn't just 5G on steroids. The researchers building this future see it as a fundamentally new kind of system, one that truly blurs the line between our digital and our physical realities. And this leads us to the final, crucial question that this whole technology raises. Think about autonomous cars that can literally see around corners using reflected signals, or virtual reality that perfectly maps your physical room in real time. The possibilities are immense. So I'll leave you with this to think about. What truly happens when our digital world can finally and precisely sense the physical one?